In question 9, we have a particle projected down an inclined plane with speed u. So we have our projection. We can have the angle, it doesn't really matter where it goes, but there's my angle A in there. So my initial here is going to be u cos A in the I direction plus u sine A in the j direction. Line of projection makes an angle alpha and then an alpha beta with the horizontal. So my accelerations here in the I direction, usually minus, but in this case positive, g sine beta, and in the j direction it's going to be equal to minus g cos beta. We can write our velocities out. Let's do them all here. Velocity of x, u plus at, so u cos alpha plus g sine beta times t. Velocity in the y direction, u sine alpha plus minus g cos beta times t. Displacement in the x direction, u cos alpha ut plus a half at squared, so plus half a, which is g sine beta by t squared. And the displacement in the y direction, u sine alpha times t minus g cos beta by t squared, with the half in front, or the 2 on the bottom. So we're asked to show that the range is given by something, so let's find the range when s of y is equal to 0. Therefore we get u sine alpha times t minus g cos beta by t squared over 2 equals 0. Factor out your t to get u sine alpha minus g cos beta times t over 2 equals 0. My initial time, and I'm going to get u sine alpha is equal to g cos beta times t over 2. So 2u sine alpha divided by g cos beta is the time taken to get there. So I need to have s of x at this. So s of x is going to be u cos alpha times t. So u cos alpha times 2u sine alpha over g cos beta. That's u cos alpha times t, and then we have plus a half times g sine beta times t squared, which is going to be 4u squared sine squared alpha over g squared cos squared beta. So tidying this up, we're going to get 2u squared sine a cos a over g cos b. 2 divides into 4 twice. The g will cancel with the squared, so we're going to be left on top with 2u squared sine squared a sine b over g cos squared b. So there's a lot of similarities here, so let's factor out and see what we're left with. 2u squared sine a is in both, as is g cos b. So that would leave with the first term just cos a, and with the second term it's going to be sine a sine b over cos b. Where is this going? Well, the bracket can be simplified to be cos a cross multiplying. It's going to be cos a cos b plus sine a sine b all over cos b. So cos a cos b plus sine a sine b is equal to cos a minus b. This guy here is equal to cos a minus b. So I'm going to end up with 2u squared sine a times cos a minus b all over g cos squared b. So if we jot down what they're looking for the range to be u squared over g cos squared b, which we nearly have, when we do have, times sine of 2a minus b plus the sine of b. This is the answer. So any of these really tricky questions, write down the answer when you get to this point, and you should see that for our one, if we factor out u squared over g cos squared b, that will leave us with sine a times the cos of a minus b. That's sine a cos b. And I've left out my 2 here from this 2 here. And in the tables we're told that 2 sine a cos b is equal to sine a plus b plus sine a minus b. So hopefully that gives us what we're looking for here. So RA, if we imagine A is equal to A and B is equal to A minus B. So 2 sine A cos B is going to be the sine of 2A. Sorry. We have the sine of A plus A minus B times, or sorry, plus the sine of A minus B. So plus the sine of A minus A plus B. The minus would change these signs. So that's going to give us the sine of 2A minus B plus the sine of B. And that's over times u squared over g cos squared b. And that's what they're looking for in this part A. So Q, E, D. Okay, next part. The maximum range. So show that the range R is given by, and then the max range is given by this expression u squared over g times 1 minus sine beta, when alpha is equal to beta plus 90 over 2. Well, for this to be a max expression even, can't speak, the sine of 2a minus b would have to be equal to 1. So therefore 2a minus b would have to be equal to 90 degrees, because the sine of 90 is equal to 1. So 2a would be equal to 90 plus b. So a will be equal to 90 plus b over 2. So that is true. So now if this is the case, and we're looking for 1 minus sine squared on the bottom, so sine squared a plus cos squared a is equal to 1. So this cos squared a is equal to 1 minus sine squared a, so we can place that there. So we're going to end up with u squared over g times 1 minus sine squared b times, well, we said the sine of 2a minus b had to be equal to 1, so that would be 1 plus the sine of b. And can we notice here that 1 minus sine squared is 1 plus sine b times 1 minus sine b, and that 1 plus sine b is on top, so that will cancel with that. Therefore we get u squared over g times 1 minus sine b. Is that what we were looking for? U squared times over g times 1 minus sine b. U squared over g times 1 minus sine b, which is true. And then if beta is equal to 20 and beta is equal to 0, b is equal to 20 and b is equal to 0. If b is equal to 20, a is equal to 110 over 2, which is 55. And if b is equal to 0, a is equal to 90 over 2, which is 45 degrees.